We've all been there and we've all seen it happen. We go to a bid and the bids are open. The first bid comes in at $11.5 million. The next submitted bid is a little lower at $11.4 million. Then another bid comes in a little higher than that at $11.8 million. But none of these contractors are the low bidder. The low bidder is $6.8 million. And no one feels good, including the contractor who got the job. They know they must have missed something in the documents to come in that low. However, there are those cases where a contractor comes in low, gets the job, and makes a profit. What's the difference between the estimates? How did this happen? These are just some of the questions we hope to answer in Introduction to Estimating. Hello and welcome to this presentation on construction estimating. Estimating is an art. An individual is trying to determine the probable costs of any given project before construction begins. To be successful, an estimator must consider all of the costs that could impact the project. Every item, every service, every influence must be analyzed, quantified, and priced. The construction documents are studied intently by the estimator because one of the most difficult parts of estimating is that all of this work must be done before any actual construction begins. An estimator becomes the most important person in any construction company when they can visualize every detail of the project and then accurately estimate its costs. Now, as we go through this presentation, we may refer to construction delivery methods. A construction delivery method is simply the process that a general contractor or construction manager uses to deliver the project to the owner. As an example, one delivery method that we're all familiar with is design, bid, build. This is familiar to all of us because it's been used for many years. This is when an architect or an engineer designs a project, it is sent out to bid, and then a contractor or construction manager is hired to build it. But, again, as these come up, we'll describe the process. For projects using the design, bid, build, delivery method, contractors are required to submit a competitive cost estimate. The competition in the construction industry is intense, and there are many companies competing for a single project. To stay in business, a contractor must be the lowest qualified bidder on as many projects as they can reasonably handle, all the while getting a reasonable profit. The return that a contractor earns must be acceptable to the amount of work that they have to perform, as well as the amount of risk associated with that project. The most important trait of an estimator is the ability to visualize all the different phases of a construction project. This is especially difficult considering that the estimates are prepared from working drawings and the project manual. The working drawings usually contain information relative to the design, location, dimensions, and construction of the project, while the project manual is a written supplement to the drawings and includes information pertaining to materials and workmanship. The project manual also contains information regarding the bidding process. The project manual is often referred to and mistaken for the specifications. This is because it does contain technical specifications, but the project manual contains much, much more. In fact, the working drawings and the project manual constitute the majority of the contract documents. They also define the scope of work and must be reviewed together while preparing an estimate. The drawings and the project manual complement each other and often overlap in the information that they provide. The bid submitted must be based on the scope of work provided by the owner or the owner's representative. Now it is the estimator's responsibility to ensure that everything contained in the working drawings and the project manual are included in the submitted bid. The estimator reads these documents thoroughly and in great detail. These documents have a high degree of complexity, and a single error could be extremely costly. Now, one of the first things that any estimator will do is review the plans and the project manual to ensure that they are complete. Next, the estimator will begin the process of quantifying all of the materials in the project. Every item listed in the estimate must contain as much information as possible. The quantities determined by the estimator will be used for ordering and purchasing materials in the field. Also, the quantities and their projected cost become the very basis for controlling the project once it begins. But the estimated cost of a project includes a lot more than just the materials and labor. There are direct costs and there are indirect costs. Direct costs include materials, labor, equipment, or subcontracted items, or any item that becomes a permanent physical part of the project. For example, the labor and materials for the foundation of a building would be considered direct field costs. Indirect field costs are the cost for the items that are required to support the field construction efforts. You may have heard these costs referred to as general condition costs and often referred to as project overhead costs. Now, one of the most obvious examples of an indirect cost is the site field office. This is an indirect cost. But the estimator must consider all other factors that can impact the project. Therefore, they also have to include such items as the weather, transportation, soil conditions, labor strikes, material availability, subcontractor availability. All of this information must be gathered, considered, and quantified. But regardless of the weather, labor strikes, or availability, the estimator must prepare as accurate an estimate as possible. Since subcontractors and specialty contractors perform much of the work in the field, an estimator must be able to calculate the scope of work in order to get accurate estimates from the subcontractors. Accurate, solid estimates require organization, an estimator's judgment, subcontractor quotes, accurate quantity takeoffs, and accurate data of completed projects. Completed project data is also known as historical data. Now, in the design, build, or construction management delivery system, estimating can take on a whole new dynamic, and these delivery systems have gained great popularity in the industry over the past 10 years. In the design, build, delivery system, the contractor acts as both the designer and the general contractor. In the construction management delivery system, the contractor and some of the key subcontractors are involved in the design process. They provide expertise in the construction methods, the costs, as well as managing the construction process itself. There's also what's referred to as IPD, or Integrated Project Delivery. In this system, though it is relatively new, it may involve the owners, designers, contractors, and some of the key subcontractors in the design process. Now, in some IPD and construction management delivery contracts, owners, designers, contractors, and key subcontractors share governance, risk, contingencies, and profit on the project. You can only imagine the pressure which is on an estimator in these delivery systems, as all of these delivery systems require that a contractor provide a cost estimate for the proposed project while the design and construction are in full gear. With this backdrop, let's now talk about specific types of estimates, and let's begin with a conceptual estimate. A conceptual estimate is based on a project's concept. At this point in the project cycle, all that may be available is a vague verbal or written description of the project. Typically, drawings are not available or are extremely limited, such as just a few sketches. When this type of estimate is required, it is known to be a conceptual estimate, and it requires the estimator to make many assumptions regarding the project. The conceptual estimate is used early in the design process to check to see if the owner's wants are in line with their budget, and is often used as a starting point to begin contract negotiations. During the design process, the contractor prepares and maintains cost estimates based on the current but incomplete design. This is often referred to as the preliminary estimate. At this point in the project, an estimator may be preparing estimates that are used by the contractor to select between materials or to determine whether the cost to upgrade the materials are justified. What these types of estimates have in common is that the design is incomplete. Once the design is complete, the estimator can then prepare a detailed estimate. And a quick reminder, there are exceptions to these rules, especially when using delivery methods such as design-build, where the design is being completed while construction proceeds. Now, as just mentioned, a detailed estimate cannot be completed until the design is complete. The reason for this is that a detailed estimate takes a great deal of money and can consume a great deal of time. The required level of accuracy combined with the amount of information available is going to dictate the type of estimate that can be completed. Each estimating method requires different amounts of time to complete, and thus produce a different level of accuracy. The relationship between time to complete the estimate and the accuracy of the estimate is shown here. The different estimating methods clearly shows a different level of accuracy. But once again, another factor is the amount of information available when the estimate is being performed. A detailed estimate takes a great deal of information as you're going to require quantities, costs, materials, labor, equipment, insurance, bonds, overhead, and of course, profit. Again, detailed estimates can only be completed with a complete set of contract documents. Every item of the project will be broken down into individual parts and estimated. Each portion of work that will be performed by a contractor will be given distinct labor requirements that must be estimated and priced out. Any item that will be installed by a specialty contractor must also be defined and priced. But caution is required, and estimators, when dealing with suppliers and subcontractors, need to know, will these materials be supplied or supplied and installed? Furthermore, support items must be defined in the contract. Items such as cranes, scaffolding, and other major pieces of equipment. It is the responsibility of the contractor for making sure that the scope of work is divided up among the contractor and the subcontractors to ensure that there's no overlap in responsibilities, while at the same time everything in the project is covered by someone. If we were to simplify the definition of a detailed estimate, we would have to say that a detailed estimate is detailed. It includes quantity of materials, cost of materials, required labor, cost of labor, equipment required, cost of equipment, overhead, and desired profit, not to mention all of the other items that we have discussed so far. The complexity of the project, the amount of time invested into a detailed estimate are big considerations when making decisions to move forward with the project. Next, we're going to talk about assembly estimates. In an assembly estimate, rather than bidding each individual component of the project, the estimator will put components together or into groups known as assemblies. The various components of an assembly may be limited to a single trade or may be installed by many different trades. For example, an interior door assembly might include the door, the frame, hinges, trim, doorknob, shims, and nails, as well as the quantity of each part necessary to complete the work. When creating an assembly estimate, it would be listed simply as an interior door instead of listing each individual component. Another example might be a light switch, which consists of many little parts. As opposed to listing every individual part needed, it would simply be listed in the assembly estimate as a light switch. Another more complex example might be a metal stud gypsum board partition wall. This assembly would consist of many parts and require many different trades for installation. Many high-end estimating computer programs such as WinEst or Timberline allow the user to prepare a detailed estimate by taking off the assemblies. As an example, for the switch assembly, the estimator would take off the number of switch assemblies needed for the project, and then the software would add a single gang box, cover plate, wire nuts, and so on to the detailed estimate for each switch assembly. This simplifies the estimating process and increases the productivity of the estimator. Assembly estimating is also useful for conceptual and preliminary estimates. By using broad assemblies, an estimate can be prepared quickly for an entire building. As an example, an estimate for a warehouse would be prepared using assemblies for the footings, foundation, floor slab, granular slab, exterior walls, and so on. This type of estimate can be prepared in hours instead of the days that one might spend preparing a detailed estimate. The trade-off, of course, is that this type of estimate has many assumptions and is less accurate than a detailed estimate. But there are advantages to the assembly estimate. As an example, a good estimate can be prepared with limited drawings. Furthermore, many estimators will use an assembly estimate as a check on a detailed estimate. Weather conditions, building materials, HVAC systems, as well as design and construction team members all change project to project. This all adds up to the uniqueness of every project. Skill and judgment must be used while preparing any type of an estimate, but especially the assembly estimate. This ensures that proper adjustments are being made by taking into account the varying conditions of each project. Companies such as RS Means and organizations like Engineering News Record or ENR publish annual guides on assembly estimates as well as square foot estimates. And speaking of square foot estimates, let's now move on to square foot estimating. Square foot estimates are prepared by multiplying the square footage of a proposed building by the cost per square foot of a previously completed building, or using some other form of historical cost data. This value is then adjusted to compensate for differences in the building's height, length, perimeter, and other factors. In some cases, a unit other than square footage is used as a means to measure the size of the building. As an example, the size of a parking garage may be measured by the number of parking spots in the garage. The information required to produce a square foot estimate is much less than what is needed to prepare a detailed estimate. This is because a square foot estimate can be prepared with a preliminary set of drawings which already has the dimensions necessary to prepare the estimate. Square foot estimates are quick and in many cases are used simply to check the budget of a project. Like an assembly estimate that is making broad assumptions, care must be taken while preparing a square foot estimate. Most notably, the historical data or previous data which is being used to determine the cost per square foot must resemble as much as possible the proposed project. Once again, companies such as RS Means and organizations like ENR, Engineering News Record, publish annual guides that contain a range of unit costs for a wide variety of building types. These guides include a number of adjustments that must be made to compensate for the various building components, including location, size, quality, etc. Now there is also what is known as parametric estimates. Parametric estimates use equations that express statistical relationships between building parameters and the cost of the building. The building parameters used in the equation may include gross square footage, the number of floors, the length of the perimeter, the amount of the building that's going to be used for common space, and so on. For the equation to be usable, the parameters that are going to be used in the equation must be determined early in the design process. Otherwise, the equations become useless. Parametric estimates, though similar to square foot estimates, are far more complex. Parametric estimates use log functions, ratios of the parameters, multiplication of the parameters, and in some cases even more complex equations. Parametric estimates are useful for preparing conceptual estimates based on assumptions of key building parameters or estimates based upon early designs. But again, like square foot estimates and assembly estimates, parametric estimates use assumptions, and therefore you want to ensure that the historical data being used is as similar as possible as the proposed project. Next up is model estimating. Model estimating uses computer-generated models to prepare the estimate based on a number of equations answered by the estimator. Model estimating is similar to assembly estimating, but it requires less input from the estimator. For example, an estimate may be prepared for a warehouse by answering the following questions. What is the length of the building? How many bays are along the length of the building? What is the width of the building? And so on. Based on the answers to these questions, the model prepares a preliminary estimate for the project. Logic is built into the model, such that the model selects the necessary components for the estimate based upon the answers to these questions. As an example, the size of the spot footings that are going to be in the center of the building supporting the roof are selected based on the area of the roof that the footings are going to support, which is going to be equal to the width of the bays multiplied by the length of the bay. The length and the width of these bays are going to be calculated from the first 4 questions which were previously shown. And here are those questions again. Now, a big drawback on this type of an estimate is that it focuses on the building. In other words, it ignores any kind of site work or excavation costs that may be required. Therefore, those costs have to be added in separately to get a full picture of the project costs. But again, a big advantage to estimating models is the fact that they can be complex, preparing a detailed estimate for the entire building or a simple estimate preparing a preliminary estimate for only a portion of the building. And again, it cannot be overemphasized, any type of an estimate such as model estimating which uses assumptions, be sure that your historical data is as accurate as possible. Another type of estimate is the project comparison estimate. These estimates are prepared by comparing the cost of a proposed project to a similar completed project. When preparing these types of estimates, the estimator will start with the cost of a completed comparable project and then make some adjustments for the differences between the two projects. For example, an estimate for a large apartment building may be prepared from an apartment building that was completed in a nearby city with the same plans. In this example, the prices for the completed project are available but need to be adjusted for inflation, changes in availability of materials and labor, as well as any code changes that may have taken place or are unique to the new location. When doing these types of estimates, the site itself should be estimated separately as the site conditions can vary tremendously from location to location. Now, since there are so many areas in the construction industry where the knowledge of estimating is absolutely necessary, let's now talk about some of the areas where estimating can bring in additional opportunities. A general knowledge of estimating is required by anybody involved with or associated with the construction industry. From the junior estimator who may only be estimating specific material quantities and pricing, to office personnel who may be asked to order materials for a project. Estimating knowledge is needed to do the best job possible at the most competitive cost. Others involved in the estimating process include project designers, drafters, engineers, contractors, subcontractors, material suppliers, and material representatives. As an example, architectural offices need estimates throughout their design processes. Preliminary estimates, cost evaluation during drawings, and final estimates are all prepared during the design processes at architectural firms. For projects built using the design build or the construction management delivery system, the preliminary estimate is often used during negotiation with the general contractor. Once the general contractor is hired, the general contractor's estimator will prepare the remaining estimate. In large offices, the estimating may be done by an estimator who was hired primarily to do all of the required estimating for that firm. In many offices, the estimating may be done by the chief drafter, or the head or lead architect, or perhaps someone else in the office who has developed the required skills to do the estimating. There are also estimating services and consultants who perform estimates on a for-fee basis. In an engineering firm, there may be civil engineers, structural engineers, mechanical engineers, electrical engineers, and geotechnical engineers. All of these disciplines have design phases which require preliminary estimates and final estimates. These estimates are prepared throughout the design phase, similar to an architectural firm. When it comes to design bid build projects, typically it's the general contractor who will do a detailed estimate which is used to determine what they're going to charge for the required work. Here, the estimator will have to take off the quantities, determine the cost of materials, what it's going to cost to get the materials to the site and install them, as well as assemble all the bids of the subcontractors, as well as determine the costs of insurance, permits, office staff, and so on. In smaller companies, one person may do all of the estimating, whereas in larger companies, several people may work together to negotiate a final price with an owner to provide a competitive bid. On projects built using the design build or construction management delivery system, the contractor's scope of work involves providing assistance to the owner beginning in the planning stage and continuing through the actual construction of the project. Under these delivery systems, the estimators will also provide preliminary estimates and then update them periodically throughout the project until a final price is set. Now, in many cases, an estimate may have to be prepared using the quantity surveys provided by some other design professional. When this is the case, specifications of the contract and the material requirements must be reviewed closely. Also, the drawings must be reviewed to determine the type of construction and the possible combination of materials that are going to be used on the project. When this is the case, an estimator will spend portions of their time getting prices from subcontractors and material suppliers, while using other portions of their time deciding how to work most productively and most economically. Subcontractors also need estimators. Subcontractors can be individuals, companies, or large corporations. They are typically hired by the general contractor to perform a particular portion of the project. Subcontractors are specialists within a specified field and provide expertise in areas of construction including excavation, concrete, masonry, interior finishes, roofing, and so on. For many years, the use of subcontractors to perform all of the work on a project has been an acceptable business model. The advantage of this business model is that general contractors distribute the risk associated with the project to a number of smaller companies or business entities. But the other big advantage is that subcontractors are specialists and understand their costs better than anyone. Therefore, their historical data is typically deadly accurate. Of course, the disadvantage to hiring many subs is that the GC winds up relinquishing control and becomes more of a coordinator than a direct supervisor. But again, the subcontracting business model works as subcontractors carefully check drawings and project manuals to submit a price to the GCs that will be bidding on the project. Prices given by the subcontractors can be in the form of a unit price or lump sum price. If the price is presented in what will be charged per unit, then it is a unit price bid. This may be per square foot, per block, per cubic yard, and so on. However, even when presenting a unit price bid, subcontractors need to perform other calculations for the business, such as at what stage will they be needed? How long will it take to complete the work? How many workers will be required? And how much equipment will be needed? A subcontractor needs to complete an estimate to determine a reasonable amount of overhead and profit. Typically, as the quantity of work increases, the associated unit cost job site overhead decreases. For example, if the cost of mobilization for a 100 linear foot curb project is $1,000, it is $10 per linear foot. However, if the quantity had been 1,000 linear feet, then the cost per linear foot would be $1. Now this is true because the mobilization costs don't change. You still have to get trucks to the site, workers to the site, set up safety barriers, and so on. Now, if a subcontractor submits a lump sum bid, then he or she is proposing to install or furnish and install a portion of the work. As an example, the bid might state something like agrees to furnish and install all Type 1 concrete curbing for a lump sum of $12,785. Depending upon the size of the firm, the subcontractor estimator could be a full-time position or part of other duties assumed. They could also be working on purchasing materials, helping to schedule projects, working on required shop drawings, and marketing. Material suppliers also need estimators as they submit price quotes to contractors and subcontractors to supply materials required for the construction project. Virtually every material used on the project will be estimated and multiple price quotes will be sought. Estimators check the specifications and the drawings to be certain that the materials being offered meet all of the requirements of the contract and the proposed delivery dates. Manufacturer representatives represent certain materials, product suppliers, and/or manufacturers. They spend much of their time visiting engineers, architects, subcontractors, owners, anyone involved in the construction industry to let them know about the availability of their product as well as its uses and approximate costs. Manufacturer representatives are, in a very real sense, salespeople, providing expertise on the materials that they supply. They're welcomed by the engineers and the architects and are known for having expertise within their product lines. Manufacturers' representatives will carefully check the specifications and drawings to be certain that their material or product meet all of the requirements of a project. If the specifications exclude their product, they will call the appropriate design professionals and make an attempt to make an adjustment to the documents. In many cases, manufacturers' representatives will create a cost analysis of what their material will cost compared to other products. There are also project management companies who provide assistance in planning and the construction process. Part of these companies' responsibilities are maintaining the progress of the project, but also updated financial information regarding costs. Owners, private and public, will typically hire such companies to assist them in large projects. In most cases, the company will have an internal staff member work with the outside agency doing estimating on the cost of the project. And it's worth noting that whenever a government agency is involved in any phase of construction, personnel with experience in construction and estimating are required. And almost any project that requires government funds will require internal and external employees who are familiar with estimating. They'll be preparing both preliminary and final estimates for the project. This only scratches the surface of estimating opportunities in the construction industry. There's also residential construction, infrastructure projects, and private owners who are looking for assistance in estimating with their projects. And in many cases, a talented individual will step out on their own and do freelance estimating for any organization. But what's important to note here is that acceptable estimating methods can be taught. Experience and judgment cannot. Inexperienced estimators can be warned against potential errors, but good judgment can only be obtained over time. And now, ladies and gentlemen, we would be derelict in our duties if we didn't go through some estimating examples. So just ahead are some examples of conceptual estimates. So as we go through these estimates, keep in mind again, they are conceptual. They would be done in the conceptual phase of the project. And also keep in mind that the accuracy of a conceptual estimate is minimal. It is typically plus or minus about 25%. They are designed to simply give an owner an idea, a very general idea of the cost. And if they agree or disagree with that cost, they can make their go or no-go decision on the project. Now, we've already talked about an estimator's skill, judgment, and the methodology that they use to come up with an estimate, and these are critical factors in coming up with a good, solid number. But also needed is going to be a well-defined scope of work, as well as appropriate preparation time to do the estimate. If you ask an estimator for a quick estimate, that's exactly what you're going to get, a quick estimate. And lastly, even to get a quick estimate, you're going to need some sort of reliable cost information, some form of historical data to use to come up with that estimate. Now, also needed, even in a conceptual estimate, are other such items as size of the project, location of the project, start date, finish date, and current or expected market conditions at the time that the project is going to take place. Now again, this type of estimate is typically done in the initial project planning stage, and if you have decent historical data, you can take that accuracy from plus or minus 25% down to maybe plus or minus 20%. But again, in order to do that, we need to have historic data. And in many cases, this is based on the cost per bed or the cost per room or some other variation depending upon the project type. As an example, if it's a school and the school costs $1 million and there's 10 classrooms in the school, you would say each classroom costs $100,000. And then you could apply that to a school that's going to have 20 classrooms, and you'd say, okay, 20 classrooms is going to be $2 million, and so on. Hey kid, knock that off. Now, one way to do a conceptual estimate is using historical cost data as well as current cost data in the form of indices. So we have what is called the HCI, or Historical Cost Index, and we have what is called the CCI, or the Current Cost Index. Now we get these indices from companies such as RS Means or Engineering News Record, who gather this data, analyze it, and then determine the index. There may be an index for labor, indexes for material, and in some cases an index for an entire city. And that is going to be the first conceptual estimate that we do. Let's assume that we're asked for a conceptual estimate for a building that we're going to construct in Boston. And a similar building was completed in New Hampshire, but it was completed in 1992. But we do know that in 1992 the building cost was $2.5 million. Well, here we can simply set up a simple equation like so. We have the New Hampshire cost over the New Hampshire index equals the Boston building cost over the Boston index. Now, we know the cost of the building in 1992, it was $2.5 million. The New Hampshire index, which is going to be the historical cost index, can be looked up in RS Means or ENR or other organizations. And we can also look up the Boston index, which is, we're going to say 199.1. This is going to be the current cost index. So now we can simply plug in our numbers, and again we have the New Hampshire cost, and that was $2.5 million back in 1992. The historical cost index is 32, and this is going to equal the Boston building cost over the Boston building index, or the current cost index in Boston. And therefore, if we simply cross multiply, we should come up to an answer of $15,554,687.50. But we're going to go ahead and round that off to $15,554,690. Now, if you don't know how we came up with that number, all we're doing is solving for the Boston building cost. So in this equation, what we would do is take the $2.5 million multiplied by the current cost index of 199.1 divided by the historical cost index of 32 would give us, or solve for, the Boston building cost. So let's go ahead and try another one, and if you want to pause the video and see if you can calculate it on your own, feel free. But we're going to say that we're asked for a conceptual estimate for a building in Warwick, Rhode Island. And a similar building was constructed in Tallahassee, Florida in 1999. In 1999, the building cost $5.5 million. Now we're going to go ahead and look up our indices, and we find out that the Tallahassee cost, or the historical cost index for Tallahassee in 1995 was 35, while the current cost index in Warwick, Rhode Island is 182.1. So again, we are going to go ahead and set up our equation. We have the cost of the building in Tallahassee in 1999, $5.5 million, over the historical cost index, again for Tallahassee, of 35, is going to equal the Warwick, Rhode Island cost of the building over the current cost index for Warwick, Rhode Island of 182.1. And when we do our cross multiplication, we should come up to an answer of $28,615,720. And again, we're rounding this up from $28,615,714.29. So now let's go ahead and do a conceptual square foot estimate. These types of estimates are based upon the building's use, and an estimate of this type would be done when only minimal project information is available and perhaps the approximate size of the building. So these kinds of estimates take into account a little bit more information. They do take into account the size, as we stated, but they also take into account location as well as quality, and therefore are a little bit more accurate, typically about plus or minus 15%. So in this scenario, we have been asked for a conceptual square foot estimate for a motel. And again, when you do motels or schools or something of that nature, you can do it per room or per classroom or per unit and so on. So here we're going to be coming up with a conceptual square foot estimate for a motel which consists of 50 units. So one of the first things that we want to do is look up the historical cost data of a motel room. So what you see here is simply a table that you would see in RS Means, or you might see a similar table in Engineering News Record of historical costs for various buildings. Over on the left you see motels, and then you also see nursing homes, but this is just a close-up view of a much larger table. If we were looking at the whole table, you would probably see other items such as banks, jails, post offices, and other types of buildings. Now, since this is a conceptual estimate and we are planning on using unit costs, we can see up here the list of unit costs. But we also see that it is broken down into 3 separate categories. So here we can actually adjust our price for quality. The 3 categories are quarter, median, and 3/4. The median cost represents the cost at which 50% of the projects used to gather this data are more expensive and 50% of the projects used to gather this data are less expensive. The 3/4 value suggests a higher quality. Here we're talking about a higher quality project where only 25% of the comparable projects are more expensive. And this also relates to the 1/4, where 1/4 suggests a lower quality, where only 25% of the projects used to gather the data are less expensive. Now we're doing a conceptual estimate and we are doing it per unit. So where it is bolded in red, we see per rental unit, total costs, and then it says unit. And for the cheap unit, it's $35,800 per unit. For the median, it's $68,000 per unit. And for the high quality, $73,500 per unit. Well, we're not going to build any junk, so we're going to go for the high cost. We're going $73,500 per unit for our motel. So we can now calculate a base cost. So again, our motel is going to have 50 units in it, so we're going to take the number of units and multiply it by the $73,500, and we come up to $3,675,000. Now again, this is just the base cost. We still need to make adjustments for size, location, and other items. So let's go ahead and move on to the next step, but our base price is $3,675,000. So now we have a base cost for our 50-unit motel, but one of the first adjustments that we have to make is an adjustment for size. So let's go ahead and take a look at how we're going to adjust our cost for the size of our motel. So this table also can be found in RS Means, and it tells us the gross square foot area of a room for a motel. And as you can see, for a low-end motel, it is 360 square feet, while for the median motel it was 465 square feet. But for the high-end motel, again, our motel, nothing but the best, 620 square feet per room. So now here we're going to take the 620 square feet per room multiplied by the 50 units that we plan on building, and our motel is going to be 31,000 square feet. But here is why we have to make this adjustment. This table tells us that the average hotel size, based on the data that we've used so far, was 40,000 square feet. Therefore, we have to make an adjustment. This adjustment is based upon learning curves. In other words, when a construction crew is putting up a large building, such as a motel, when they complete the last room, they're going to be far more efficient than they were at room number 1. And in this example, when our crew reaches room number 50, they too are going to be far more efficient than they were at the first room. But in our case, our hotel is actually smaller than the average hotel. Therefore, we will never realize the full efficiency of our crew. So a cost adjustment for size has to be made. So we're going to get a size factor, and then we're going to get a cost modifier using the graph in the upper right-hand corner. You can take a look at that, but we'll be showing a larger version of this in a moment. But I'd also like to call your attention to what we've done so far. We've made an adjustment for quality based on the cost of the room, and we are now making another adjustment based on the size of the motel. So you may recall that our first conceptual estimate was accurate plus or minus 20%. This estimate is a little bit tighter, and I hope you can see why. It's plus or minus 15%. Certainly not numbers I'd run to the bank with, but it is a bit tighter than our initial conceptual estimate. Now the way we get our size factor is the following, and I want to be clear, this is not the cost modifier. This is the size factor that's going to give us the cost modifier. We get the size factor by dividing the proposed building area by the typical building area, and this will give us the size factor. In this case, it's 31,000 square feet, the size of our 50-room motel, divided by the typical motel of 40,000 square feet, gives us 0.775. But we're going to round this up to 0.8, and then we're going to take a look at the cost modifying graph. So here is our cost modifying graph, and as you can see, we have a cost modifying curve. And down below in the X scale is the size factor, and then in the Y scale is the cost modifier. Now notice the cost modifier curve. As it passes through the X and Y axis at 1 to 1, there would be no adjustment in the cost. However, as the size factor increases, the cost modifier comes down. Again, this is because the larger the building, the more experience the crew gains, and therefore that efficiency is worked in to the cost modifier. So here at 0.80, we come up to the cost modifying line and then move off to the left or to the right, and we come up to approximately 1.03. One could argue we're at 1.05, but for this exercise, let's assume that we are at 1.03 as a cost modifier. Now we apply our cost modifier by simply taking the base cost and multiplying it by the cost multiplier. So $3,675,000 multiplied by the 1.03 cost multiplier gives us a cost of $3,785,250. So now we have made an adjustment for size. The next step is to make an adjustment for location. This table shows us just a few of the some 200 cities from which RS Means gathers construction costs. They get costs for labor, materials, and in some cases, whole systems. But they also create indices for individual cities. But using a table like this means that the national average index would be 100. But once they took a look at the data, the most expensive city to do work in was New York City, with an index of 130.7. The least expensive was Texarkana at 76.1, and the city closest to the national average was Salem, Oregon at 100.2. These indices are bolded in red as the weighted average for those cities. So again, here are those city cost indices for those three cities that we just stated. Now we're going to go ahead and adjust our price for location and determine what the cost of our motel would be in these three cities. And here we can use the same equation as before. We have a base cost, which has already been adjusted for both size and quality, of $3,785,250 over the national index of 100 is going to equal the adjusted New York cost over the New York index of 130.7. And again, if we cross multiply, we should come up to $4,950,000 to build our hotel in New York City. Of course, we started with a very low base number. There's no way we're going to build a motel in New York City for $4 million. We're not going to build one for $14 million. So, again, the base cost was low, and that's why the number is low. So just a quick review of how we've come up with this number so far. Again, we started off with a motel, and we wanted to build a motel with 50 units. To adjust for quality, we used the $73,500 per unit. This here was the 3/4 range from the cost, gave us a base of $3,675,000. We adjusted our size by taking the 620 square feet per room times the 50 units, gave us 31,000 square feet. But the typical motel was 40,000 square feet, which gave us a size factor of 0.8. This size factor gave us a cost modifier of 1.03, which gave us a new base price of $3,785,250. We just adjusted for New York. Let's go ahead and adjust for Texarkana and Salem, Oregon. And for Texarkana, if we cross-multiply using the Texarkana index, we should come up to a cost of our motel in Texarkana of $2,881,000. And lastly, Salem, Oregon, closest to the national average, $3,793,000. And you can only imagine how much tighter we could get this number if we began to do estimates on individual items such as labor, materials, equipment, inflation, escalations, market conditions, and so on. And again, ladies and gentlemen, this was examples of conceptual estimates. These are estimates that a good estimator might scratch out on the back of an envelope while at lunch with an owner or a developer. And once an owner or developer sees that initial cost, he may go to another company and ask for a feasibility study to see how much money can be made from the motel, or they may ask for a detailed estimate, which is also going to cost them money. And at the end of that feasibility study or that detailed estimate, they'll make another go, no-go decision. So, ladies and gentlemen, this is going to conclude an introduction to estimating from Tech Training, LLC.